Hello, welcome. This is question 4 for Edexcel's C4 January 2007 past paper. Now, for this question, we start off with a nice and simple partial fractions. I almost said partial equations. I'm sure that's something in physics. That'll be going over soon. Whatever. Okay, so as I said, it's quite a nice, simple starter to the question, and then we go on to use this idea in solving differential equations. Now, obviously, that will become apparent as we move through. And then the part C is just kind of, part B is finding a general solution, and the part C is finding a particular solution. As I said, that will become apparent as we move through. But really, particular solution just means finding the value of the plus C when you solve the differential equation. But let's kick off with part A, weirdly enough. So the partial fraction. Now it said split 2x take 1 over x take 1 to x take 3 into partial fractions. It didn't give you this format. Now, as I said, sometimes it does. But because this is just two factors, it's not a repeated factor, it's not a repeated linear factor, sorry, or it's not multiple factors. It's a nice, easy partial fractions. It's the easiest one you're probably ever going to get. Okay, so different ways of looking at it. The way I look at it is, well, obviously you put A over the first factor and B over the second factor. Okay, that's standard. But as I said, the way I look at it is you times all of it, so both sides. This is essentially an equation now, and we're trying to find values of A and B. So what I would do to start off with is times all of the bottom, so all the denominators by, times by both sides of the fraction by the denominator of the two factors. So the denominator, of the thing you're trying to split up. So in this case, we times both sides by x take 1 to x take 3. So obviously that leaves just 2x take 1 on the left hand side. And when we times A over x take 1 by x take 1 to x take 3, the x take 1's cancel, so therefore we're just left with A times 2x take 3. In the case of B, the 2x take 3's cancel, and we're just left with x take 1. As I said, you could just look, okay, well, B has the factor of the one that's under A, and A has a factor of the one that's under B. But that only works when we've got an equation when we've got a partial fraction like this, where we've just got two factors. So that's why I prefer this method, which is a lot. You can apply it to any partial fraction question you might get. Okay, and then the next stage is obviously just choosing a suitable value for x. So basically, we want to get A or B on its own, and we want to therefore make the other factor. So if we're trying to find A, we want the factor of B to be 0. Similarly, if we want to find B, we've got to make the factor of x equal to 0. So as I said, the x take 1 is the factor I'm going to make equal to 0 first, because it's the easiest. So therefore x must be 1. So you're not going to put on your next line, or wherever you're writing, x equals 1. And then it's just a case of subbing in x to be 1. So 2 times 1 take 1 is equal to A times, now it might be easy just to go straight into it. So 2 times 1, obviously 2, take 3, it's minus 1, so that's minus A, or just minus 1. Now you could write B times bracket 0, but we know that's going to get rid of it. As I said, it's up to you, but it depends what kind of time pressure you're under in your exam, if you are returning to this question. But if you want to do it fully, you might as well just do P bracket 0, but I mean it's pretty pointless either way. Okay, so 2 times 1 take 1, it's obviously minus 1, is equal to minus A, so therefore A must equal minus 1. Okay, right, so therefore the next one we're going to choose, we want to make the factor of A equal to 0. So this might be a little bit more complicated. Well, it's not complicated at all, but it's just nice to be able to make sure you're always right. So 2x take 3, we want that factor to be 0, so therefore 2x must equal 3, so therefore x must equal 3 over 2. Now I wouldn't write 1.5 because, well, that's just a bit messy really. Okay, so 2 times 3 over 2 take 1 is equal to, obviously A is going to have a factor of 0, but you might want to write it here anyway, plus b times 3 over 2 take 1, or 3 over 2 take 2 over 2. It's completely up to you. Okay, so 2 times 3 over 2, but that's obviously going to come to 3. 3 take 1, well that's obviously 2. A is going to have a factor of 0, so b times 1.5 take 1, which is a half, or 0.5, so it's just b over 2, okay? Times both sides of the equation by 2, so therefore we get b is equal to 4, okay? And that was just a case of rewriting it in. Now you could simply just write minus 1 over x take 1 plus 4 over 2x take 3, but I think it's a little bit more, a little bit more intelligent to, even though I wrote a and then b in terms of that way round, I just assumed that a was going to be positive, but obviously we know it isn't, so instead it's up to you, but I'm just going to write it as 4 over 2x take 3, because they're not asking for the values of a and b, they're just asking to put it into partial fractions. It doesn't matter which way round you put the factors, it just happened that I chose a to be above x take 1, okay? But you might have chosen that to be part b, sorry, not part b, b, but as I said, it's up to you. So 4 over 2x take 3, take 1 over x take 1. Alright, so that's it in partial fraction form. As I said, quite a nice, easy start to the question. Now what I'm going to do is just rub off this rather crude working, because, well, let's be honest, it's easy enough, and I'm sure it's on the mark scheme, okay? Well, I'm sure it's on the mark scheme. I mean, every step I did should have been on there anyway, because, well, basically the mark scheme is written by the examiners just as a basic thing, so the other examiners, they don't have to write too much, but just so that, you know, if you're trying to look as a mock exam thing, you don't get the full picture. Obviously that's why you do it. Anyway, okay, so that was part A, so that's nice and simple. Part B is a little bit more complex, but it seems almost impossible to do, but if you think about it as we've just done this partial fraction, so we're going to have to relate this idea of partial fractions, of literally what we've just done, to solving this differential equation, then it should be fairly straightforward. But as I said, you know, with the heat of the exam, you might not see it. And trust me, when I did this as a mock, I did feel the heat of the exam. It was a class mock, it wasn't, you know, otherwise it'd be pretty stupid, because we did the C3, we haven't done, anyway, shut up. So, 2x take 3, brackets, x take 1. Looking strangely familiar to this, the denominator of the what we tried to split up. And actually that's associated with dy dx. And we are told that is equal to 2x take 1 times y. Oh, look. On the left hand side, we've got, I've wrote it the other way around up here, but we've got the denominator of the partial fraction. And on this side, we've got, well, granted we've got it times by y, but what we've got on this side is we've got the numerator of the partial fraction, of what we split up into partial fractions. Interesting, that. Okay, right, so what we want, because obviously it's going to be very, very hard if we didn't know about this, or if we didn't think of this, to just go ahead and do this. So what I'm going to do is divide both sides by 2x take 3 and x take 1. So it's 1 times dy dx. Now you might want to go straight to the next step as well, so sort of skip the step out. But as I said, you know, I'm going to keep it nice and simple. So it's 2x take 1 times y, and that's all over the x take 1, 2x take 3. So now it's looking like the fraction we had before. Okay, before we split it up into partial fractions. Now, because we've got a y on this side, what we want, obviously we want it in terms of y, so y equals something. We've got here, we've got 1 times dy dx. Now, we obviously want that in terms, maybe, we don't want y on this side, because we're going to move the dx to this side, so we want the left hand side in terms of y, the right hand side in terms of just x. So basically we divide both sides by y. So it's 1 over y, and that's just with respect to y. We integrate that, okay, put a little integral sign, and then we do the integral sign next to 2x take 1 over x take 1 to x take 3. Okay, and that's with respect to x. Now, sorry, got ahead of myself and started rubbing out the question. Now, how does this help us? I mean, we know it's split up into 4 over 2x take 3 and 1 over x take 1. How does that help us? Well, the first thing that I'm going to do is, before I answer that question, just it's like watch the adverts kind of thing, but there's no adverts with mine. Not that they're paying me for anyway. So if anyone out there wants to reach the 6 viewers I get every single day, please do let me know. And them 6 viewers be myself. Okay, so right, I do apologise if the actual focus has been out this entire time. I suspect it has, but never mind. Okay, so as I said, what we do now is what I'm going to do is just write in this fraction, single fraction here, into the two partial fractions. I'm not going to solve anything just yet. So it's 1 over y with respect to y equal to the integral of 4 over 2x take 3 take 1 over x take 1 with respect to x. Okay? And what we're going to do now is solve this. So the left hand side should pop out you straight away, that's an ln. But it's an ln of y. Okay? So the ln of y. That's equal. Okay, so the reason we split this up is because we want to turn it. We can't integrate that straight away. That'd be insane. I don't know what you would do with that. Apart from this, you'd split it into partial fractions. And the reason we've done that is to help us, because the only way we can integrate these now is in terms of ln. Okay, so it's not just ln of 2x take 3, because the differential of 2x take 3 is 2, and on the top here we've got 4. So we need to get from 2 to 4. So it's times it by 2. So therefore we times the ln of 2x take 3 by 2. So it's 2 ln of 2x take 3. Now arguably you could put that as ln of 2x take 3 all squared, but I wouldn't just yet. Okay, and then let's take the ln of x take 1, which you don't have to times anything by, because the differential of x take 1 is simply 1, which is what we've got, and we just take it away because, well, we've got to take away something there. Okay, so it's all looking fairly standard. Now we need to obviously put the plus c on the right hand side, because there is a plus c for both sides, but because as I mentioned with these kind of questions, there's a plus c for the left hand side and a plus c for the right hand side. So when you take two real numbers away from each other, which is what this c represents, then we end up with another real number, just a smaller or bigger real number, whatever it might be. We're not interested, we just know it's another real number, so we just leave it as a plus c. Okay, so we want it in terms of y, and that's very good, but I mean, what can we do now? Well, you have to think, okay, well, e's cancel out ln, so exponentials, that's what I mean by e's, cancel out ln. So if we e both sides, so the first side is nice and simple. When we e an ln, you could write e to the power of ln y, but the e and the ln's cancel, so it's just y equals. Actually, no, sorry, I do apologise, you can continue going that way, but just, if you haven't, it doesn't matter if you have, this is just an alternative way. Actually, no, just trying to think which would be easier. Yeah, if I explain this way, and then I could show you, if you've already started writing y equals something, then I can show you how you can go from that. But if you just, for them people, if you just want to listen, and then I can show you how to correct it if you want to. You're not done anything wrong. I've just skipped ahead of myself. So therefore we've got y equals. So we've got the ln of y. That obviously just comes to y. Oh, God's sake! I really rhymed myself. Right. Sorry, I do apologise. So ln of y is equal to. Now these ln's are what we call natural log of x. So hence we're a logarithm. So we use log rules, like I mentioned before, that the power rule. Now when we take away logs, we divide them. Okay, so what we've got really here is sorry, Because it asked us to work out what the plus C is. Sorry, I do apologise. I've worked out what plus C is before I've actually... Sorry, I do apologise. This hasn't gone to plan, but never mind. This is question 4. I do apologise. Alright, okay, so, sorry, that is your answer to part B, there. So this ln of y is equal to 2 ln of 2x take 3, take ln of x take 1 plus c. Now, to find what we call the particular, this is what was messing my mind because I started to work out c and the answer for b was that and I was thinking, what? Because generally you would see it in terms of y, but we can't work it out in terms of y before we work out what plus c is. Okay, so, and that'll become clear as we go through the question. Okay, so the boundary conditions, or what we're told to help us to work out c, is that when y is equal to 10, x is equal to 2. So when y is 10, so you just put when y is 10, x is equal to 2. Okay? So it's just a case of subbing these values into our general solution. So it's the ln of y, we know y to be 10, so the ln of 10 is equal to 2 ln of, well, we know x is 2, so it's 2 times 2 take 3, which is the ln of 1, but, you know, we can go to that in a minute. Take the ln of x take 1, which is the ln of 1, plus c. Now, the ln of 1, well, we need to think, well, you could just put it in your calculator, you will find out that it is 0, because basically, e to the power of something, well, because we use, it's best of explaining this, right? So e to the power of something equals 1, and that is 0. So this ln stuff, I think I did explain it in another question, but I'll just give you a bit of background. So, you know, as I say, you can just skip a few seconds if you want to. Just explaining why the ln of 1 is 0, okay? So basically, whatever this value is, in this point it's here, it's 1, okay? If we put the ln of that in, we get 0. Similarly, if we put, if we're trying to find out, so if we've got a value of say 3,221.2, okay, and we know that is e to the power of something, this is just an example. Say we call that x, okay, and we want to find out what x is. Now you could use logs, but just standard logs, C2 logs, but that's an exponential, we need the natural log of x. So use the same kind of theory, so what you do is you ln both sides, so therefore x is equal to the ln of this 3,221.2. So similarly in this case, if we ln both sides, then what we get is, so the ln of 1 is 0, okay? Because so that's why the ln of 1 is 0. If that makes sense. If it doesn't, as I said, it doesn't really matter. Just using standard log rules. But it's just a bit of background, okay? So therefore, if ln of 1 is 0, this is 0, this is 0. So it's 0 takes 0 plus c is equal to ln of 10. So therefore, c must equal the ln of 10. So you might want to rewrite this whole equation, I'm just going to rub it out, as ln of y is equal to 2 ln of 2x take 3, take the ln of x take 1, plus the ln of 10. Okay, now where do we go from that? Well, as I was mentioning before, we use our standard log rules. So when we take away 2 logs, we divide them, and when we add a log, we times them. So what we're going to do is work out, sorry one sec, I'll just put this back to how it was before. Do apologise. Okay, so I'm going to continue with this then. Before I e both sides, so the ln, I'm just going to follow the log rules and simplifying it using logs. Okay, so it's 2 ln of 2x take 3. But this 2 ln x of 2x take 3, we're going to use the power rule for that. So it's the ln of 2x take 3, that's all squared. Okay, so simplifying it down in stages, take the ln of x take 1 plus the ln of 10. Okay? Alright. So now we can use the log rule. So the ln of y is equal to the ln of 2x take 3, and that's all squared, but you put a little inside of that. So it kind of looks like you've got a double bracket situation, really. So it's the ln of 2x take 3 all squared, and then inside that ln bit, we do it over x take 1. But because we're adding ln of 10, we times it all inside this little bracket by 10. So it's 10 brackets 2x take 3 all squared over x take 1, and that's all being ln'd. Okay? Now it's just a case of e'ing both sides. Right? So therefore, if we e ln of y, we get y, and if we e the right hand side, we just get 10 2x take 3 squared over x take 1, and that is your particular solution. Basically, because it's not got a plus sign, we call it a particular solution. Okay, so that's question 4. Hopefully you can see how we related the partial fractions and why we needed that. That last little bit, a little bit of a mucking up, and I did a bit of an explanation of why ln of 1 is 0. But as I said, hopefully you understand that. If you want me to do it again, please do let me know. I feel I've probably not done so well on this paper. Since I've got the answers right, but I've just mucked it up one or twice. But I've picked up on every mistake, and I've been over my other ones, and know the mistakes have been made. So as I said, there's always a mark scheme online. So thanks for watching, and we'll see you in question 5.